Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. MCPBA is an epoxidation reagent that converts alkenes to epoxides. In the presence of H+, MCPBA still primarily acts as a peracid epoxidizing agent. The key question is which double bond gets epoxidized preferentially. Moving on to the next step. Identify the two double bonds in the starting material CH3, C, CH3 is equal to C, CH3, CH2, CH is equal to CH2. Double bond 1, the internal, trisubstituted, or tetrasubstituted, alkene, C, CH3, is equal to C, CH3. This is a more substituted, electron-rich, double bond. Double bond 2, the terminal alkene CH is equal to CH2. This is a monosubstituted, less electron-rich double bond. Moving on to the next step. MCPBA preferentially epoxidizes the more electron-rich, more substituted double bond. The internal double bond C, CH3, is equal to C, CH3, is more substituted and more nucleophilic, so it reacts faster with the electrophilic peracid oxygen. And for the final step, epoxidation of the internal double bond gives an epoxide bridging those two carbons, leaving the terminal vinyl group, CH is equal to CH2, intact. CH3, C, CH3, C, CH3, CH2, CH is equal to CH2 with an epoxide, O bridge, between the two central carbons and the terminal double bond remaining unreacted. Option A epoxidizes the terminal double bond, less substituted, which is not preferred. Option C shows a diol at the terminal end, which would result from osmylation or acid-catalyzed ring opening of terminal epoxide, not the major product here. Option D shows a diol at the internal positions, which would require ring opening of the internal epoxide under the given conditions, just H+, not aqueous workup emphasized as ring opening step. The epoxide itself is the major product. Therefore, the correct answer is B. Therefore, the correct answer is option B.